Hi, welcome to my YouTube channel Vaishnav360. Like, share, subscribe, and do not forget to hit the bell icon.
Guys, welcome to Vaishnav 360. Today we are going to do Roman number 2. But before doing Roman number 2, we should know few symbols through which we can do all the problems in Roman number 2 in exercise 1a functions. So, these are the symbols. We will read now. If a comma b belongs to R, a is smaller than equals to b, then a comma b is equals to a belongs to R, that is a smaller than x, x is smaller than b. A comma b with right side block bracket, then x belongs to R, a smaller than equals to x and x smaller than equals to b. A is smaller than x and x is smaller than equals to b. If left side block bracket and a comma b, then x belongs to R, a is smaller than equals to x and x is smaller than b. A comma b with both sides block brackets, then x belongs to R, a that is a smaller than equals to x and x is smaller than equals to b. A comma infinity with left side a block bracket, then x belongs to R and a smaller than equals to x. X comma infinity with both sides curved brackets, then x belongs to R, a greater than a smaller than x minus infinity comma a with both sides curved brackets, then x belongs to R and x smaller than equals to x smaller than a. If there is minus infinity a with right side block bracket, then x belongs to R and x smaller than equals to a. Okay, I think you may see now. These two I have read. Okay, so now we will do the Roman number 2 problems from the next page. Okay, so now we are going to start the Roman number 2 first problem. Before starting the problem, we should read the question. What is the question here? If a is equals to x modulus minus 1 smaller than equals to x and x smaller than equals to 1, f of x is equals to x square, g of x is equal to x cube. Which of the following are surjections? First one, f maps a to a, and second one, g maps a to a. Now we should find which one is the surjection. Is it the first one or the second one? Okay, now we are going to start the problem. First we will represent a set. Okay, a set, there is minus 1 and 1 here. In between there will be 0. In between these there will be so many points like uh, 0.9 here, 0.8 like that. Here also like that. Okay, there is 2 a's, right? So here also one more. Okay, here one, because there here a to a is there, so here a to a only will be represented. Now the first step in the problem is, first step is we should do first point first, right? First point is f maps a to a. Okay, first step is, let us assume that y belongs to a, f of x is equals to y is equals to x square. Okay, y belongs to a, here anywhere y belongs to a. Okay, and f of x is equals to y is equals to x square. Now x square is equals to y, we can take like this now. Then we should find out x. X is equals to root y, square root y. Okay, now we should find out, is it surjection or not. To find out surjection, we should let y is equals to minus 1 comma x is equals to root minus 1 belongs does not belongs to a, right? It does not belongs to a. Root minus 1, minus 1 into minus 1 is 1. To be a surjection, y is equals to y should be 1, but here it is minus 1. In x, if there is minus 1 root, then the answer is 1, so it does not belongs to a. That's why it is not a surjection. Okay, I think you may understand this. We'll do this next one. The next one is G maps A to A. Okay, now we should do G maps A to A. Second one. Yeah, we should write therefore. This is very important. Okay, therefore f is to means f maps A to A is not a surjection. Okay, I forgot to write this, sorry, but I have written now. Now we should do the second one. What is it? G maps A to A. Okay, G maps A to A. Okay, now let us take or assume y belongs to A and g of x is equals to y is equals to x cube. Then we can take x cube is equals to y and x as cube root y. Okay, now let us assume that y is equals to minus 1. Then x is equals to minus 1 belongs to A. Okay, as here y is minus 1, we will take here 3 under cube root minus 1. Minus 1 into minus 1 into minus 1. So minus 1 into minus 1 is plus 1. But again there will be a multiplication with minus 1. So the answer will be minus 1. What is y? Minus 1. And then x is minus 1. That's why x and y belongs to A. So we can say that it is a surjection. Therefore G maps A to A is a surjection. Okay, now we will go forward for the second problem. So now we are going to do second problem, first bit. Okay, now solution. Let x1 comma x2 belongs to R, then f of x1 is equals to f of x2. 2x1 plus 1 by 3 is equals to 2x2 plus 1 by 3. Denominators cancel. 2x1 plus 1 is equals to 2x2 plus 1. Then here this one cancel, and okay, now then 2x1 is equals to 2x2. If we multiply this and get here, it will be denominator as usual, it will cancel. So from here only I will cancel. Now the answer is x1 is equals to x2. This is an injection. How to justify it is an injection? We should we should first know if the x1 is equals to x2 is same. x1 and x2 are same. So we have proved here that x1 is equals to x2. So we can justify this as an injection. The statement is f maps R to R from x f of x to x plus 1 by 3 is an injection. Okay. Now we'll go ahead to the second bit, projection part now. The first step is let us take y belongs to codomain. Y belongs to R is equals to y is equals to 2x plus 1 by 3 and 3y is equals to 2x plus 1 and 3y minus 1 by 2 is equals to x. Now this is the first point. Okay. Now we will do the following. Given f of x is equals to 2x plus 1 by 3 is equals to 2 of 3y minus 1 by 2 plus 1 by 3. Okay. Now next it is 3y minus 1 plus 1 by 3. Here 2 and 2 will get cancelled. 2 here and 2 here get cancelled. Next step 3y minus 3y by 3. Here this and this get cancelled. 1 is equals to y. Okay. I think you all understand. So f of x is equals to y. Therefore f maps R to R f of x is equals to 2x plus 1 by 3 is a surjection. Okay. Now we will go to the next bit. Here we go for the second bit. Before telling you what is the answer for the second bit, I want to tell you if the problem first one we have got that it is a surjection and it is an injection. So if there is both condition in it, then it is an bijection. I forgot to write, sorry, but the end answer of the first bit is bijection. Okay. Now we will do the second bit. First step is let x1 comma x2 belongs to R comma f of x1 is equals to f of x2. Therefore 2x1 is equals to 2x2. The bases are same, no? So we can directly write it as x1 is equals to x2. So we can directly say that it is an injection. F maps R to R, not R to R, R to 0 comma infinity. F of x is equals to 2 to the power of x is an integer. Injection. Therefore, f maps R to R, that is f maps R to 0 comma infinity. F of x is equals to 2x is an integer. Sorry, it is an injection. Again and again I'm getting it is an integer, but it is an injection. Sorry for the misspell. Okay, now we will do the surjection part. Surjection part. Let us take y belongs to 0 comma infinity, then y is equals to 2 to the power of x, then x is equals to log y 2. Why we have taken like this? We have a formula that if I will write here a to the power of x is equals to n, then x is equals to log n to the power base a. Okay, this is the formula I have applied here, this formula, and I have got log base 2 y to the power y. Okay, this will take as first equation. Now given f of x is equals to 2x to the power of 2 to the power of x is equals to 2 log 2 as the base and y as the power. Okay, this is from, I took this from the equation here. Okay, from the equation 1. Now f of x is equals to y. Okay, now therefore f maps are to 0 comma infinity, f of x is equals to 2 to the power of x is an surjection. Here it is an integer, a injection and a surjection. So we can conclude it as a bijection. Okay. We are going to do the third bit. Okay. In third bit, what is the question? F maps 0 to infinity to R. So and then defined by f of x is equals to log e to the power of x. So we should do the problem now. We will do the problem and get the solution correctly. Okay. Now let's write the first point, that is solve. Let x1 comma x2 belongs to 0 comma infinity, then f of x1 is equals to f of x2. So now log base e x to the power of log base e to the power of x1 and log with base e x to the power e to the base e to the power of x2. Sorry for spelling it wrongly, but for a little confusion I have did like that. Now you will be clarified. Okay, now it is log e with base e, log base e to the power of x1, and this is log base e to the power of x2. Okay, now we will do the next point, that is we can directly say this one is same, this one is same, only these both are different. So now we can directly write x1 is equals to x2. Okay, through this we can know that this is an injection. Okay, now y belongs to R and y is equals to log e to the power x, and base e is equals to e to the power y is equals to x. X is equals to e to the power of y. Here you may get doubt how I did log with base to the power of base e to the power of x to e to the power of y. Now there is a formula here x is equals to log with base a to the power of n is equals to, we can write this as a to the power of x is equals to n. So I have written here like this. This and this is same. So only variables are different, that's why the answer is different. Okay, for this is here, and we should do total surjection, right? To do surjection, f of x is equals to log to the base e to the power x is equals to log base e to the power e to the power y. Got this is x is equals to e to the power of y, right? Here x is there, and here I should substitute what is x. X is, what is x? E to the power of y. So I substituted e to the power of y. Okay, is equals to, we have a formula through which we can take the powers and multiply them. So y multiplied by log base e to the power of e. Okay, this is the formula, don't copy it. Okay, this is the formula. Okay, what is log? We have a formula for log base a to the power of a, that is 1. Log power a base a is equals to 1. Okay, we have a particular formula. So same variables here, same variables here, so 1. Here both are e only, right? So we can write it as y into 1. Okay, now the answer is y. F of x is equals to y. Therefore, by this we can say that this is a surjection. Alright, this is surjection and injection also. So we can write it as, therefore it is totally a bijection. It is totally a bijection. Okay, this is the answer for the third bit. We'll go to fourth bit. So now we are doing the fourth bit. What is fourth bit? Fourth bit is nothing but f maps block bracket with 0 comma infinity curved bracket to again the same block bracket 0 infinity to curved bracket. Okay, defined by f of x is equal to x square. Alright, done. We are going to solve this problem now. What is the solution first? First step of the solution is, let us take, if you take injection, then we should take x1 and x2. If we take surjection first, then we should take as x, y is equals to x. Okay, now we for every problem we are taking x1 and x2, that is integer, so we'll continue here also as an integer. Okay, let x1 comma x2 belongs to block bracket 0 comma infinity curved bracket, then f of x1 is equals to f of x2. Okay, now x1 square is equals to x2 square. How did I did this? Here f of x is equals to x square. That's why if there is f of x1 here, then we should substitute x1 instead of x. So I have substituted x1 here, so it is x1 square, and here x2 square. I hope you understood how I did this. Now we can cancel this both. When powers are same, we should remove the powers. So we get that x1 is equals to x2. Therefore, we can prove that this is a surjection. Sorry, injection. Okay, injection. I was a little bit confused. That's why it's an injection. Okay. Now we will do the surjection format. We will do the surjection format. Okay. Now surjection format. How to do surjection format? We should take x is equals to y. Okay, let y belongs to block bracket 0 comma infinity, y is equals to x square and x is equals to root y. Okay, if we transfer square here, then it will become root, so it is square root. We can take it as first equation. Then given f of x is equals to x square. Okay, x square. Then what is x? X is a root y, so we should take root y whole square. So square and root cancels, then it will become x, y. So f of x here becomes y. So we can tell that this is a surjection. From here we can conclude that therefore f maps block bracket 0 infinity curved bracket then again to block bracket 0 infinity curved bracket f of x is equals to x square is a surjection. Okay, totally we can conclude it as therefore totally it is a bijection. This is the main answer. Okay, now we will go forward to the fifth bit. So we will do the fifth bit now. What is fifth bit? Let's discuss first. Fifth bit is nothing but f maps r to block bracket 0 comma infinity defined by f of x is equals to x square. Same as the fourth bit, but there is a little change. Here from r to block bracket 0 and infinity. Before it was both the same, block bracket 0 infinity to block bracket 0 infinity. This is range, I think so. Okay, or there may be taken r as a set. Okay, r to this thing or range to this thing. Okay, now we will do the first step for the solution. Let x1 is equals to x1 comma x2 belongs to r. Okay, f of x1 is equals to f of x2, then x1 square is equals to x2 square, same as the before problem. Okay, now x1 this cancel, x1 is equals to x2, but here a small change. This is from real number to a block bracket 0 as a set. Okay, then we should take x1 is equals to plus or minus x2. Okay, because it belongs to real numbers, we cannot conclude that it is plus or minus. That's why we should take as x1 is equals to plus or minus x2. So here the answer is we cannot. Therefore f maps r to block bracket 0 comma infinity is not an integer. Sorry, little confused. Real numbers and integer I was confused, so I have called this as integer, but it is an injection. Sorry, injection. Okay, this is injection. This is not an injection, we can conclude, because this is plus or minus. If there would be only plus or only minus, we would conclude it is an injection. If there was minus and minus here, we can cut this and make it plus. That's why we can call it as injection. Okay, now we'll go to the surjection form. Now we will do surjection form. Okay, now in surjection the first step is let y belongs to block bracket 0 comma infinity, then x square is equals to y. X is equals to root y, as the square is transferred to root. So we will take this first equation and then given given f of x is equals to x square is equals to root y whole square. As the same as previous problem I have did no, same it is, so I am not explaining now. Okay, why? Now f of x is equals to y. Okay, now through this we can conclude that therefore f of x is equals to y. Here 0 comma infinity is a surjection. So totally it is a surjection but not injection. So therefore it is not a bijection. It is not a bijection. Okay. Now we will head towards the next bit, sixth one. Now we are here in the sixth bit. Sixth bit. Okay. Sixth bit. You may confuse as sixth problem. It is a sixth bit. Okay. Here I have written already, let us take x1 and x2 because every problem we should do the same method, right? So that's why it is a time waste, uh, again to write, again to do. That's why I have written already the statement. So we will directly jump into the problem. Before jumping into the problem, we will discuss what is the question. Okay, f of sorry f f maps R to R defined by f of x is equals to x square. It is, I think so, it may be a identical function. Okay. Um, Now we will go to the problem. Okay. Here for injection we have did here. So x1 whole square is equals to x2 whole square. Okay. x1 is equals to x2. This we have got the first one, but here it is from r to r, that is real number to real number, then it is plus 1 minus 1, so it is not an integer. It is not an integer, sorry, injection. I was literally being confused between injection and integer. Sorry guys for this misunderstanding of mine and uh, your confusion. It is injection. If I told anything in spect of if I told injection, it may be okay. If expect I have told injection as integer or anything, I am sorry guys. Now we will continue. This we have completed, right? Till here injection form has been completed. Now, yeah, now we will go to surjection form. Okay, let y belongs to R. Then for element that belongs to minus infinity comma 0 codomain of f has no pre-image in f. You might think that what am I doing by writing an introduction like this or written explanation like this. For this we have no problematic form to do because there is no pre-images in f for a codomain of f. Okay, now we have no pre-images, so we cannot do the problem. So we can tell that it is not an, therefore we can tell that it is not a surjection. Okay, totally we can tell it that it is not a bijection also. It is not a bijection. Okay, we'll go forward to the next problem, second one. No, third one. So we are in the third question. We will do what is third question. We will know what is third question first and then solve the problem. What is third question? It is nothing but is G is equals to 1 comma 1 2 comma 3 3 comma 5 4 comma 7 is a set that is a function from A to B. The A set is 1 2 3 4 and the B set is 1 3 5 7. Okay, if this is given by the formula g of x is equals to ax plus b, then find a and b. Okay, now we should find here a and b when the formula is given that g of x is equals to ax plus b. Now we have got the sets a and b and the set g also after uh, getting a function that g is from a to b. Okay, now we should solve the problem. Okay, we are solving the problem now. Get started with your pens. Okay, now we should take the given first. A is 1 comma 2 comma 3 comma 4. Okay, we have got here in the question that a and b 3 comma 1 comma 3 comma 5 comma 7. Okay, these two are given and again we have got g 1 comma 1 2 comma 3 and 3 comma 5 and 4 comma 7. Okay, we have got these three. So g of 1 is equals to 1, g of 2 is equals to 3. Now g of 3 is equals to 5 and g of 4 is equals to 7. You might think how did I got this? Now A is, what is A? A is domain, right? And B is codomain, no? So G1, G1 is 1. Okay, G2, G2 is 3. Okay, G3 is 5. Okay, G4 is 7. I think you might understand this. Now we will continue. Okay, all this I am doing is for your benefit so that you might understand and score good marks in the exams. Okay, the next step is we should write a statement. So for each element I am writing this for your understanding. Okay, for each element A belongs to capital A, those exist a unique B belongs to capital B. We think we have heard this before. Yeah, we have heard this before in the introduction of the functions. We have got this in one of the definitions we have read. What is that definition? Comment in the comment box. Okay, what is the definition? You should comment me. Okay, I will wait for your positive response and the answers in the comment box. Okay, so for each element A belongs to a capital A, those exist a unique B belongs to capital B. Okay, then such that A comma B belongs to G. Therefore G maps A to B is a function. I think you might got where we have you might get or your brain got striked from where we have got this unique b belongs to b. Okay, the answer is there in the sheet only, guys. You can comment and tell me what is the answer. Okay, now uh, the next step is given. What we have given, the formula we have wrote everything above, no? A b g. What is left over? The formula. So g of x is equals to ax plus b. Okay, now we should find out what is g of 1. Okay, a of 2 plus b of b is equals to 3. Sorry, I have misread it. First, this is g of 2. Okay, now this is g of 1. I'm writing down the g of 1. Okay, now g of 1 is equals to a of 1 plus b is equals to 1. Okay, we will write this opposite, because in multiplication, sorry, in addition or subtraction, if there is addition we can add it simply and move on. Okay, but in subtraction this is different, so I am going to do it oppositely. Okay, now first of all we will write this, the answer for this. Okay, plus b is equals to 3 and a plus b is equals to 1. Okay, now I am going to write down like this: a plus b is equals to 1, 2a plus b is equals to 3. Okay, we should subtract this. Okay, minus 3 plus 1, what is it? The answer is minus 2. Okay, now minus b plus b cancel, minus 2a and a, minus 1a. Okay, now minus here cancel, a 1a or a is same, no? A is equals to 2. Okay, now the answer we have got is a equals to 2. Sorry, now you might see. Okay, now uh, now we should a substitute a is equals to 2 in this is right, this is first equation and this is second equation. Okay, now we'll substitute it in second equation, equation 2. Any equation you might substitute, but I am taking equation 2 because it is simple. A is equals to 2, right? First we will write the equation. A plus b is equals to 1. A, what is a? A is equals to 2 plus b, we have not got b. B is equals to 1. B is equals to 1 minus 2. So what is b? B is equals to minus 1. This is the answer what we get. A is equals to 2 and b is equals to minus 1. Okay, therefore we can write totally a is equals to 2 and b is equals to minus 1. This is the answer.